Hey there, Math Moment Makers. John here from Make Math Moments, and in this video, we're going to help your students with division, and there are some things that you need to know. So we're going to show you what you need to know so that you can teach division to your students effectively. Before we get into it, hit the subscribe button here over on YouTube, or if you're on Facebook, hit that kind of bell so that you get notified when we have videos that go live or when we share them. Okay, so let's get into this video. You're going to see a clip, or I guess it's longer than just a clip, of Kyle and I talking to the members of the Make Math Moments Academy. Every month we go live with our members to talk about pebbles in their shoes and how we can help them. And in this month, in this video, we talked about division and what are the things we do need to know so that we can teach this well to our students. When I learned division, I just learned it, very long division-y, or I learned it with this goes into this, and but there's more to it than just that if we're going to teach it well, and we're going to talk about that in this video. So you're going to see that live session, Kyle and I in there with members of our Make Math Moments Academy members. So have a great watch and stay tuned to see how you can get into the Academy afterwards.
All right, so here we are. We've got 12 cookies, and let's just like free flow here. Don't worry about raising hands. We're going to cut each other off and all this stuff. That's fine. We're a small enough group. But I'm curious, can somebody give me like a context? If we're talking about cookies and we're going to deal with like, the idea of cookies and plates, right? We're going to be using division. Can somebody set me a context here? We're going to try to keep the numbers nice and whole. So like 3 or 4 is probably good, or 6, whatever you want to use. Can somebody help me out with a context?
Four people shared 12 cookies. How many cookies did each person get?
Awesome. So 4 people shared 12 cookies. Now, I'm wondering, and I'm just going to go like this just to kind of divide us up. I'm wondering if I gave this to, I'm going to say like a kindergarten student, how many people feel like they'd be able to accomplish this task? They might need the cookies. They might need, like they're going to be able to do this job, right? I'm wondering if you could pretend that you're that student who doesn't realize this is even division. Like, this is the worst thing we could possibly do with kids, is say like, I'm going to teach you division. Rather, we're just going to give them a scenario and we're going to say like, do it. And then we're going to worry about naming it later, right? In Sean's case, it's a little different, right? Because your kids know division, like they've heard of it. So it's going to be a little different. But go ahead and tell me, like, what would
I was just going to say, should we mention that they're equal?
Love it. Love it. 12 cookies and
4 people all get the
like
same number or something.
Yeah. Or equal, or anything like that, because like, some students might say, well,
give him 1.
Yeah, you didn't.
12 for me.
I want more. Yeah. Absolutely. So this would definitely be worth reiterating for sure. How might a student go about actually doing this work? What do you think? Feel free to yell it out, anyone. How do you feel? And this is where we're talking like strategy, like what would they actually do if they had these 12 cookies?
I'm thinking simulating taking the 12 cookies and passing them out one at a time to each person, like rolling out a deck of cards and making sure each person gets the same number of cookies until I run out, is what I would think a younger child would do.
I love it. So I've got like 12 cookies here, and you're kind of like almost picturing like, you're like, okay, well, here's like one person, here's another person, here's another person, here's another person. And you're kind of almost like saying, okay, well, like 1 for you, 1 for you. And they might like physically move them, or they might, if they were drawing it, if they were at a stage where they're comfortable, right? And they're doing this. And actually, like, what would you call this strategy? Like if you had to say like what I'm doing right now, like what am I actually doing with these cookies? Did I do that right? 1, 2, 3, 4. 1, 2, 3, 4. Whoa.
That should be red there.
Haha. 1. So maybe not all students will, or they can and I just can't. But either way. All right. So it's like basically they're like, wow, okay, I'm going to have like basically 3 cookies here. I'm wondering, like, what would you call this process, what we just did over here?
Is that the fair share idea?
Yeah, we're going to call
Fair
that
share.
fair sharing.
That's cool.
Okay, now this is like a strategy, okay? And it's like a super intuitive strategy. All right. And now this particular scenario actually calls for this distribution of, the cookies in an equal fashion. Now, I'm going to tell you though, there's actually, when I said this, I was rolling the dice that basically you were going to either do this scenario or you were going to introduce another scenario. However, as soon as I say cookies and people, most people default to this scenario right here. They default to this idea of like, you're picturing it like, oh yeah, just like make sure, share it out. But I'm going to tell you, there's like another type of division. There's another way we can say this problem. We can even keep the number 4 the same, but something different about the number 4 is going to happen here. And I'm wondering if anyone's like, brave, maybe some people have been doing some work with division, so they've got it. What are we thinking? Like how could I say this scenario? I'm going to even say, like, if I say 12, and you and I know, we wouldn't do this with kids if they didn't know this was division yet, but I'm like, you and I know that this was 12 and we divided by 4. But what I'm telling you is I can do 12 and I can divide
by other numbers.
Well, I'm going to divide it by 4 again, but I'm going to tell you the result is going to be the same number, but it's going to be different. And you're going to be like, what the heck is happening? It's going to mean something different, just like Sean said.
I don't think you can see the chat, right? Kelly is saying she's like thinking about multiplication, like thinking backwards, like 4 times 3 is 12.
I love it. Now, here's the deal. In both these scenarios, I can do what Kelly's doing. I can use this inverse, this reciprocal, not reciprocal, but inverse relationship between multiplication and division, regardless of which way I go. But those numbers are going to have something different about them. And we're going to talk about that a little bit more. John, you want to practice your skills? Because like you said, you want to, like he's newer in this journey. So
yeah. Well, this is, I think because we've done this problem before, but this is the scenario that we would, your pose is that we have 12 cookies, but now we want it to be 4 cookies per person. How many people do we need?
All right. So I'm looking for basically I'm looking to figure out how many people can I invite to this party? Over here, I was like, mom's like, I have 12 cookies and we've already invited 4 people. How many will everyone get? We want to use all the cookies. Right. Whereas over here, we're saying, listen, nobody leaves this house without having 4 cookies. And we're not going to leave anybody without cookies. So you're only allowed to invite the number of people that you can feed 4 cookies to, right? Super unhealthy habit to get into, but that's what we're saying over here. And this is something very different. Let's look at this for a second on how this would happen. I want you to think this felt really easy. And I'm going to say, this is sort of like, I'm going to say this is where we tend to introduce division to kids. We say, hey, here's division, do this. And then kids are like, great.
I'm thinking right now, Kyle, this second solution, the one you're asking for, feels like it would be easier to draw, easier to say, show that solution. Because if you draw the 12 people or the 12 cookies, the 12 cookies, not the people, and I circle 4 of them, that's 1 person right there. That's an easy diagram. That's an easy strategy. I'm just going to grab 4, boom. That's 1 person for sure. But the interesting thing is now it's I don't know how many. Is this going to go? Am I going to have enough full people here? It's I get 3 full people. And I really like that. It's all of a sudden, imagine we did 13 cookies and what would this look like? Rather that, Sean, that's where that remainder was coming in. It would be completely different with if we had 13 cookies and then I circled the 4 people, 4 people, 4 people, I'd have 1 extra cookie left on that side. Now, if we did the 13 divided by 4 with, we're taking 13 cookies and we're sharing them with 4 people. It's there's an extra cookie that now has to be divided up into 4 people, it's all of a sudden this extra remainder clearly has this definition of a third, and it's like,
Yeah.
whereas now it's like the other remainder over here is like, wait a minute, how do I can't make 4 people out of that.
And John, you're like articulating why division is so important, especially when we get into places like proportional relationships and proportional reasoning, is because even when we're solving equations, we tend to solve equations only using one type of division when there's actually 2. And actually the context drives the type of division that you should be using. So we say it all the time. It's almost like we're so trained to like strip context from problems. We go, this is a word problem. It's hard. Take numbers out and do stuff to it. Take numbers out and do stuff to it. But what that ends up doing is it actually, in this scenario, what it would be is like, hey, well, if I'm telling a student to fair share in a context that isn't fair sharing, you can imagine how messed up that would be for a student. They're like, I don't get this. And you're like, what don't you get? And the reason I don't realize why they don't get it is because I don't realize there's 2 types of division, right? I'm sitting here teaching one type likely, depending on my grade level, and we're going from there. So something that's really interesting is that in both cases, Dan, I want to highlight this. This is important. You'll notice in all our units, we always talk about the types of division as they come up, and we really try to hone in on this. You'll notice that the units here in the first scenario and the second scenario, our dividend has the same unit. It also has the same quantity in this case, but you'll notice the units are the same. Nothing's different about that. Over here, what does 4 represent in this scenario? Like, what would its unit be? Because we talk about multiplication and division with sort of like these naked problems, and the number will come out right. But let's talk about like, what is the 4 here? What does it represent?
People.
People.
And on the other side, it's cookies.
Over here, I'm gonna leave this one for a second because we could put cookies, but I'm gonna add in a little tiny secret sauce there that will make you look at it differently forever. Okay. My wonder though is, what is this number then? Like, what do we call this number over here?
Well, my kids hate the
not
word.
what I call it. What's the unit? I should say, like 3 whats.
My kids hate the word per.
Mm.
It makes no sense to them. When they look at the word per, they drop out like that's a word I've never heard in my life. So I would like to use 4 or something else in there.
Okay. I wonder though, so think about this though. Your students are in grade 6. They've been dividing for 3, maybe 4 years.
4 years, yeah.
And they don't like the word per. To me, I see a connection here, and I see there might be a very important reason why they don't like it is because it's been hidden from them and they don't know where it came from. But I'm going to tell you right now, the unit right here is 3 cookies per person. And the reason that they don't like it, again, is because it probably came out of nowhere. But something very important about this problem is that what we have here is we've revealed a rate. In this scenario, when we are fair sharing, when we are dividing with the intent to take a quantity and to chop it up into fair groups, we are finding or revealing a rate, is how we like to say it. So we're actually revealing the rate here, and we're saying the rate is 3 cookies per person in this scenario. Now, to me, that might not seem that important on its surface when we're looking at this scenario, but think of the implications later when we get to ratios and rate, and when we try to explain what a rate is to students, and we can't relate it back to the fact that every rate in the known universe is found through this type of division, and it has different names. Some call it rate division. The wording that we use on our units all the time is partitive. And I saw it in the chat. I think it was Sean S. that may have said partitive in there. Partitive. And that sounds complicated, but the part that I really want you to focus on is the fact that we took these 12 and we've actually partitioned it. Whoops, I did that wrong. Oh no, it's so permanent now. Holy smokes. One, now I got to use a different color. Come on. So here we go. It's like I've partitioned it into 4 chunks. And I did it in an equal fashion. This one with partitive, it's like, I want to chop it up. I know how many parts. I know that there are 4 parts in this particular one. Now, I could say that for the next 400 years, and you're still going to mess it up a billion times. And it's okay. John, me and John know this. We do webinars on this and we still mess it up sometimes. But this rate is so important. The question I have for you now, and I'm going to go back, and I think it was Sean, Sean number 2 tonight, who came in, Sean B. You were going to name this, I think, if I recall. What is this? Or what's the unit for this particular scenario over here? When actually, I think I see it somewhere else. It's like I gave it to you, I robbed you.
The quotative?
Yeah, oh yeah, the type of division is called quotative.
Oh, cool.
But the unit for this number 4, you can see it right here. Look at this, cookies per person.
That's the rate.
So think about this for a second. Now, early on with young children, like in grade 3, I'm not going to stress over, first of all, I'm not going to stress over the names, but I am going to give them contexts that are this, contexts that are that, contexts that are this, contexts that are that. What do you notice? What do you wonder? What are you seeing? And something you're going to note is that John's method here of like making groups, it's almost like they're making groups and throwing it away. Making a group, like take 4, throw it over there. Take 4, throw it over here. Here, they're taking 1 at a time. Now later you could, if you know it's a huge quantity, you could do 10 at a time if you want, but you're still kind of guessing. You're kind of working your way up to the rate. Over here, it's like, I know exactly how much I need. I'm going to grab them, throw them over here. This strategy, anyone want to like dare name what this strategy is? Like what's happening? You named this one. Someone said fair sharing. What is it that John did here when they were like, I'm just going to group up 4 at a time?
Grouping.
Grouping works. I like it. There's one that we often name, like it's like subtraction. When people say subtraction is takeaway, that's only one type of subtraction. There's more than one type of subtraction. Blow your mind, right? It's like, what the heck? I thought it was takeaway. Nope, that's only sometimes. Over here, we often call all division repeated subtraction. And the reality is that repeated subtraction, while you could say you're repeatedly subtracting 1 at a time here, the way people tend to say repeated subtractions, they say, well, you're going to take away 4 every time. If you try to do that strategy over here, you are changing the context of this problem. If you try to go take away 4, take away 4, take away 4, you'll end up with 3, but then you're going to have to figure out what's the 3 mean, and it's not going to make any sense. Over here, I'm literally starting with 12, and John was like, well, group 4, I'm going to take away 4. I'm going to group 4, I'm going to take away 4. I'm going to group 4, I'm going to take away 4. So over here, this is like this repeated subtraction over here. That's like a strategy that works over here in this quotative scenario. We're given the rate. We're dividing by the rate. Over here, we're revealing the rate. So essentially, in every division problem in the known universe, you're doing one of these 2 things, and you've always been doing one of those 2 things. You just didn't probably make, or maybe some of you did. I know I didn't make the connection that that was actually happening. Right. How nuts is that?
Yeah, it's super super eye-opening to see that it's clear now that we're revealing the rate, or you're dividing with the rate, and we've always blended the questions together. I guess, Kyle, the next question I think I'm going to put for Sean's purpose here is like, okay, let's say now we know this as teachers. How much do I reveal of this? Because I'm going to hurt I'm gonna hurt kids' minds if I start talking about both of this and these names and like what part of this do I reveal to kids, and how do I use my knowledge now that I know the two types so that kids can understand this better?
Yeah, I love it. And for me personally, I'm all for me using the name, but not having an expectation for the students. Now, with that said, I'm not going to use the name with the intent to confuse. You know, I don't want to just keep using the name, and I might use the name and say, like, remember when we were using partitive division when we were fair sharing all the cookies?
Right.
Right. So it's like we're going to
strategy instead, right? So
yeah,
it's like
we're gonna
I fair
like, we're,
shared instead of repeated subtraction.
exactly. We're really going to focus on like the what we're doing, but also I'm not even going to worry too much about them being able to necessarily articulate it super clearly, especially early on. But what I want them to be able to do is I want them to be able to take a context and I want them to do what their instincts tell them to do. And if you really think about it, in both these cases, I'm going to argue that every student in the known universe, if you were to say, I've got 12 cookies and I want everyone to get 4 cookies, let's figure out how many people we could feed. I guarantee you they could get down here. They might not realize that that was a rate. They might not realize, you know, like there's going to be things that they will need to develop over time, but they'll be able to solve the problem. The part that they can't do is when kids come home, like my daughter, I know I'm being recorded right now, but my daughter comes home with naked division problems and I create contexts for them because my daughter came home and it wasn't 12 divided by 4, but it was like that. And my daughter's like, I need to do that thing with the 2 dots in the line. And she's in grade 3. And I'm like, oh, I'm like the thing with the 2 dots in the line. I'm like, I've never heard of that type of math, right? So then she brings it out. And then so I would give her the context and I would keep mixing them up. And I would just say like, don't worry. I'm like, don't worry about that. I just want you to solve this other problem. She's like, I got to get my homework done, Dad. And I'm like, no, come over here. And I, lay out 12, cubes or whatever. She does all the math. And then we come back here and she goes, oh, so then I have her add in like, what is it? 12 what's? And, what's the 4 mean? What do you want it to mean if it's a naked problem? And I'll tell you, that is going to be something that honestly, Sean, if I want to get your thinking first, but then also when you go with your students, you're going to probably have to, like we're all grown adults and we did cookies and we did, these are known facts that all of us know here, but yet I'm sure many of us are looking at this going like, whoa, this is like heavy, right? Like there's a lot going on here. So something that is worth noting here is when you're doing partitive division, typically what you're going to notice is that you're going to have 2 separate or 2 different units, like very clear units going on here. Now, this is something you want your students to notice. We only have an hour together, so it's like not like we get to work on this for the next few days together. So I might not bring this up to them right away, but you're going to notice this is for us as the facilitator. It's like, when you're dealing with, and oftentimes people have a definition of a rate is when you're comparing 2 multiplicative or 2 quantities with different units, people call that a rate oftentimes, but that's kind of too simplistic because it's because of partitive division that actually happens. Whereas over here, you wanted to say, I think, Sean, you said 4 cookies before, which is a way you can look at it with your students as well, that when you're dividing and you're comparing 2 of the same unit, right? So you could consider this like being the same unit. You're dealing in the quotative land, right? Where you can actually repeatedly subtract. Here, I can't repeatedly subtract 4 people from 12 cookies. When you think about, and it's almost like from a conceptual standpoint, you're like, oh yeah, that doesn't make any sense. I can't take away 4 people from 12 cookies. Oh, that's because I have 2 different units. And what I'm going to be revealing is the rate. I'm not actually going to be just repeatedly removing 4 cookies at a time like John did.
Good.
So there is a lot there. And I will tell you, Sean, first off, they're in grade 6. They're going to really want to just do a procedure. Something else I'll mention is the long division algorithm tends to play in this land. When we do something like if I was to write this as like 4 like this, think of the language we tend to use with this right here. We tend to say 4 goes into, right? We tend to say like 4 goes into 12 how many times. And what we're really saying there is like, how many times does 4 go into 12? Well, what do? In this case, it would be a known fact. But in reality, it's like, what I could do is I could go, well, let's take away 4. I'm going to do, so there's one group of 4. Okay, now I have 8. Okay, let's take away another group of 4. Like this whole long division thing, it's so interesting to me how we make it like, if a kid doesn't know how many times 4 goes into 12, they're stuck on that. But right here, it's like, well, no, I'm just going to like take away 4. I get 8. I'm going to take away 4 again. Oh, now I get 4. Oh, wait, that's another one right there. 4 and oh, okay. Now I'm left with 0. Oh my gosh, 1, 2, 3. There's 3 of them. But you've used the language of quotative division. And you can imagine why so many kids struggle with long division if the language is only quotative, but yet they're using it all the time. I can still use long division with this, but I have to change my language, as you said, right? You're like, the language is so key. We have to keep track of what it is, what we're actually trying to accomplish, you know?
Introducing the units that way has been so huge without telling the kids we're going to be doing this, or you're going to use this method or whatever.
I love it.
I was able to do the same thing with multiplication when I gave them a problem just like that for multiplication with candy pieces, I think.
Yeah, like Sean, that is exactly how, you know, we try to frame out the problem-based lessons, right? Like that approach is so key, so that it almost forces them to not be able to resort to some algorithm they may have seen in passing from a previous school year. So it kind of like, it puts everybody in this, you know, state of like dissonance. You know, while you were chatting there, I was just sharing like this particular unit would be a place where you'd probably want to go after you get the groundwork with your students there, Sean B, because it is with some larger numbers. Basically, we estimate, you know, we ask how many passengers can ride. We reveal how many.
We actually did this one.
Oh, did you?
Oh, yeah.
Yeah.
So this unit will actually go through, and in the guide section, it will actually break down the different types of division for you. So in particular, like when you check out the different strategies, you'll see that for day 1, fair sharing comes up because it's actually a partitive scenario. And, you know, we can use fair sharing this way, or we could do fair sharing like with an array. And as you go on, you can eventually work your way towards a area model. And I heard partial products in the chat there. I think it was maybe Kelly who mentioned that. Partial products is super helpful strategy where students can then start making connections as to like why even the long division algorithm works, right? Like, because it does depend on this idea in order to work. And in the consolidation, we go through and we really try to highlight what type of division it was. So you'll see some of these pieces. So you'll see revealed the number of passengers per car. So it's like, oh, we were looking for a rate, and we talk about what's the same, what's the different about these two scenarios. So again, partitive, quotative. We get kids to kind of notice, like when you try to find this one, if you try to do that one the same way, you're going to run into a problem. Like the number will be the same, but how you went about it's going to be very different. So this whole unit, if you dive into the guide, the teacher guide will kind of help you see what we're trying to pull at, and sort of go through like, here's a good visual of what's the same, what's different. So we use, you know, an array. The numbers are really big, but even with like older students, we really have to have, like, they have to develop this confidence with models in order for them to have any sort of chance at being able to do this work. Because if we rush to a calculator, it's going to be too easy for them to just kind of ignore it all. And they'll just be like, well, here's the number. I'll just try to figure out what the number means afterwards. Whereas here you can kind of see a very, like a much different strategy taking place. Like here, you'll see 252 people, 42 passenger cars. The answer is the vertical quantity. Whereas over here, what you're going to find is, wait, we were given 6 per car. We were given the rate. Now the answer is the horizontal quantity. And basically what you start to see is that with division, the idea of the commutative property of multiplication really matters here, right? Because we were given an answer, and now it sort of matters which factor we were trying to reveal. Whereas in multiplication, you're like, I don't care, just going to multiply this and this, and it doesn't matter the order I do it in, even though we would argue that when we're multiplying, you are like one of the numbers represents groups, like one of them does,
Division.
even though sometimes we don't pay attention to it, and it really matters for division. So I just thought I would share that, but it sounds like you've already kind of went down that rabbit hole.
Not as much as you did. Then we'll come back. One of the things I did is, and I know we're short on time here, we do an estimation 180 every day. And what I've started to do is ask my kids to bring in their own. So if we're looking at a problem like you're showing here, see if they can model it in some way. And I have a couple, little rewards for them or whatever. It's just kind of fun. Just putting it up there is kind of a reward. But to have them design these types of things, these types of situations is absolutely pretty cool.
Yeah,
Right.
for sure.
Yeah,
it's definitely worth it. When we saw that question there, Sean, I was super excited. I think John knew I was going to be super excited. I get kind of geeked up when it comes to division. And one of the main reasons for me anyway is because, like, honestly, I'm still like, every time I do something related to division with a group of educators or a group of students, I learn something new. Like I feel like every time I feel more comfortable with it. I feel more flexible and fluent with it. And like, that's exactly what we want for our students too, right? So that repetition of re-experiencing, like not repetition through rote, but through re-examining ideas and investigations, you'll learn. Like your head, you're going to feel like a burning sensation, and you're like, in the front of your brain, and your students are going to feel it too. And what a cool way to help those students before you say goodbye to the math world.
Don't remind me, except for I love it. But I will still join you guys, because this is guys and women.
Awesome. We would love
to have you. Didn't mean to just say guys. Yeah, it's been fun, and we'll get together again. So awesome. I'll stay on your mailing list, and I'll.
I love it. I love it.
All right, there you go, math moment makers. We talked about division, and it was mind-blowing in the sense that when I first kind of became a math teacher, I didn't know there was 2 types of division, and it wasn't until Kyle had introduced it to me, and he had just recently discovered this idea that there's rates, and then there's the value or the quotient. So it's like all of a sudden it's like, you're right. We've been teaching it always one way, but we actually have to understand it in 2 ways before we can teach this well. So hopefully you got some value out of watching this session. A couple things before we go. Hit the subscribe button here here on YouTube, or if you're watching on Facebook, hit the like button so you get notified when we have videos that come out. If you are interested in joining the Academy, then what we have is the links below this video over on the webpage. We can show you how you can get your first month for free and get in on that, because in the Academy we have courses for you to learn how to do this stuff. Like we talk about division in our Fundamentals of Math course. We've got an assessment course that just came out, but also we have full tasks that you saw here in this video, and the teacher guides to show you how to do this and what techniques to talk about inside those lessons. We teach you how to run the actual lessons so that you can be successful and nail it with your students. So hopefully you got some value out of there. We'll see you next time. Take care.